Alright, Mr. Collier here with a quick video to show you how radical expressions work. Sometimes when you do radical expressions you have a square root, sometimes you have a cube root, but basically the story is you want to get everything out of the radical as much as possible, right? So let's look at this first one. We have the square root of 36. So when I do this, I know that 36 is a perfect square. That just means that the square root is going to be a whole number. So I can do the square root of 36 is 6. And I'm done. So that's the first one. Also, for the third one that we have right here, this is also a perfect square. Notice how the square root of 64 is just 8, because I know that 8 times 8 is 64. So I take it out as an 8, and I'm done. For the other two, what we're going to be doing is we're going to be breaking these up into factors. So, for example, let's look at square root of 18 right here. I know that 18 is the same thing as 9 times 2. So I can actually break this up into 9 times 2. Okay? So now I know that 18 is 9 times 2, and I know for a fact that 9 is a perfect square. Since 9 is a perfect square, I take it out as a whole number. So what's the square root of 9? Well, the square root of 9 is 3, right? So I can take out the 9 as a 3. 2 has to stay inside, since we don't know what the square root of 2 is. So that's it. Let's look at number 4. Square root of 125, well, I know that I can divide this by 5, so let's break up the 125 into 25 times 5. Okay, so I've got it broken up into 25 times 5, and I know for a fact that 25 is the perfect square, and I can take it out as its square root. So what's the square root of 25? Well, the square root of 25 is just 5, right? So I can take it out as a 5, and the 5 that's still under there has to remain under the radical. So my answer is going to be 5 times the square root of 5. Okay, so those are just numbers. But what if your problem asks for a variable? What are we going to do with these? Well, what we're going to be doing with variables is, at least for square roots, you're going to be dividing the exponents by 2. So we're going to divide exponents by 2 and see what happens. Okay, so let's work with the number first. So I know that the square root of 16 is 4, so I can take the 16 out as a 4, and I can start dividing the exponents by 2. So what's 8 divided by 2? That's just 4. So I can bring out the x to the 8 as x to the 4, right? Same thing with the y's. What happens when I divide 30 by 2? I get 15, right? So I can take out the y30 as y15, and I'm done. Okay, let's look at the next one. 63 is not a perfect square, so I can't take it out yet. I actually have to break this up into factors. So I know that 63 is the same thing as 9 times 7. So let's break this up into 9 times 7, and all the variables and the exponents are going to stay the same, at least for now. Okay, so what can I take out? The 9 is a perfect square. It can come out as a square root, which is 3, but the 7 has to stay under there. Now, when I divide the exponents by 2, here's what happens. If I take 7 and divide that by 2, I'm going to actually get a 3 with a remainder of 1. And basically, the remainders have to stay under the radical. So remainders stay under the radical. So here's what's going to happen. 7 divided by 2 is 3, remainder 1, so I can take 3 x's out, but 1x has to stay under there. The y's, 10 divided by 2 would just be 5, so I have y to the 5th. And I don't have enough z's to take out, so I'm going to leave this z under there. Okay? So what's left under the square root when we're all done? The 7. The 7 is going to stay under there. We had an x that we couldn't take out, right? And we had a z that we couldn't take out. So that's it. We're done. Okay, let's look at the 4 remaining problems. Let's see. Okay, let's do number 7. So the 4 can come out as a 2, since the square root of 4 is 2. So I'm going to have 3 times 2 on the outside. Let me draw my square root. The x's, 2 divided by 2 is 1, so I can take out x to the 1 power. 3 divided by 2 is 1 remainder 1, so I can take one of the y's out. And z to the 4th power, well, 4 divided by 2 is just 2, so I can actually take out 2 z's. And what am I left with under the radical? Just a y, right? That's the only thing that can't be taken out. So then when I simplify it all, I just have to multiply 3 by 2 to get 6, and everything else stays the same. Okay, so the name of the game is you really need to take out as much as possible. You might not be able to take everything out, but you can take some things out, right? Okay, let's do cube roots. Notice that 343 is a perfect cube, so I can take it out as a cube root, right? So the cube root of 343 is 7, so the whole thing comes out as a 7, and I'm done. Alright, let's look at the next one. 54 is not a perfect cube, but I can break it up into factors, right? Hopefully one of the factors will be a perfect cube. Notice that 54 is the same thing as 2 times 27. I know for a fact that 27 is a perfect cube, right? So let me label that. This is a perfect cube. So I can actually take the 27 out as a 3, because that's the cube root of 27. And then the 2 has to stay under the radical. Done. Alright, and the last one. Cube root of 1000 is 10. And let me do the variables now. So now we're doing cube roots. We're going to divide all the exponents by not 2, but actually 3. We're going to divide all the exponents by 3. So let's try that. Okay, the x's. 9 divided by 3 is 3, so we can take out 3 x's. How many y's can we take out? Well, 10 divided by 3 is 3, remainder 1. So actually one of the y's has to stay under there. And how many z's can I take out? 12 divided by 3 is 4, so I can take out 4 z's. So that is simplifying radical expressions. Hope you enjoyed that. Have a good day.